Next, it is my pleasure to welcome Dr. Darby McGarth, Senior Research Scientist in the Environmental Horticulture Department at Vineland Research and Innovation Center in Ontario, Canada. She's also the leader of Greening the Landscape program and works across the country to help improve tree planting successes in the nursery and landscape. At Vineland, Darby's team has researched the variety of air pruning pots available to the nursery industry and is presenting on the effect air pruning levels have on tree root systems in propagation, as well as in the field. Thanks so much. Welcome, Darby.
Thank you. So thank you, Shelby and Cheryl and everyone else who's organized the IPPS Summit today. It's my pleasure to be here virtually, of course, from Ontario and the Niagara region. I'm sorry we aren't all here in person. It would have been fun. And it's disappointing, but boy, am I impressed with the ability to run events like this right now. So thank you so much for having me here today. And as Shelby mentioned, I'm going to talk, pretty briefly about air pruning, propagation trays, and trees, which is a focus of our research lab located here in the Niagara region, and just sort of talking about what it's all about. And today, I've set the presentation up as a series of questions that we've been trying to answer, and certainly we have maybe some answers for some of these questions, maybe not all the answers. And then also some research objectives that we've been working on in our group here in the Greening Lab. So the questions today that we're going to look at are: what is a high quality tree root system? When does coarse root development start? Or I guess more importantly, when does it matter that we start paying attention and worrying about it? What types of trays and tray features can help us to achieve high quality root systems? And why do roots grow the way they do in different propagation trays or containers? So, closed walled systems versus air exposed containers. And then I'll just walk you through sort of high level, some of the research objectives that we've been tackling in our group. In a relatively short presentation here, hopefully we can, provide you with some resources you can follow up with after the fact. So what is a high quality tree root system? Unfortunately, there is no agreed upon definition, but there's certainly been a lot of research that's been looking at this over the last couple of, I would say, decades now. We look a lot into the forestry literature where they've been focusing on this in propagation for, much longer than ornamental horticulture has been focusing on it. But certainly there's some really great leaders in this field that we rely upon and we've been looking to. And one of them is obviously Dr. Ed Gilman, who is a mentor to us in our research group. And he does sort of have some definitions around what is a high quality tree root system now based on his decades of research on this. So I don't know if any of you have had the pleasure of going to one of Dr. Gilman's workshops, but he makes it very interactive and he makes you yell out a mantra during the presentation when he asks you what we should be looking for in terms of some of the photos he'll show. So his mantra is straight roots, some at the surface. And I think that's a really great place for us to start talking about what we're looking for in terms of the coarse root or the structural root system on a high quality tree. So first and foremost, what we look for is coarse roots at right angles that are close to the soil surface. So these are your laterally oriented roots, and those should be roughly at right angles. And I've highlighted it there. We also look for structural roots that are radially oriented around the trunk. So making sure that roots are, like the spokes on a bicycle wheel pointing outward from the hub. We want to make sure that there are no roots that are misdirected and pointed back towards the root system, which can alter the stability and the anchorage of the tree. We also talk a lot about misdirected roots within the root ball. So thinking about, I'm sure some of you or most of you have heard the term container imprint now, and this idea that roots can become sort of trapped within the container while they're being grown, and during different production cycles you'll see sort of different effects of that. But we certainly, when we're looking at having a high quality root system, we want to make sure that we don't have misdirected roots that are captured within the root ball. Lots of small diameter roots throughout the root ball. So a mix of this lateral root structure, which is the framework for the fine root system. And we want to be looking for, a healthy amount of fine roots throughout the root ball. And then also few roots on the outside of the root ball. And this is, this is a field dug tree, but this is really nice. I thought I would throw it in there, and it's a shout out to my brother-in-law actually, who grew it and sent a picture of it to me the other day, and I thought, wow, that's really nice. So so you can't see, on a container tree, you might have roots being captured on the exterior of the root ball as they're sort of climbing around on the side of the plastic. So we don't have that here, but that's something you want to be looking for in terms of, a high quality root system. So when does coarse root development start in trees? Obviously, it starts right away. As roots emerge, we start to see this, especially in seedlings, that we have, we have to be checking in on the quality of the structural root system from day one, or from germination, more accurately. But most of the main structural roots of the trees, the ones that we think about for anchorage and stability, those actually form within, roughly, in some species earlier, but roughly the first 2 to 3 years. And so as we're thinking about getting a good start, and Terry talked about this and others from the Bailey presentation, but that really does start as soon as we can start to see root emergence. So we need to be thinking about structural root development with trees right away, because once a defect forms, if it's not corrected, it can carry forward to the next stage of production. And quite often it does carry forward to the next stage of production. And certainly there's some species differences there. Some are worse than others. And I'm sure all of you can think of your own examples. But if you start out with sort of like this cage-like structure that we see as those lateral roots are forming, without corrections, those are just passed along the production line. And so that's what a lot of our research looks at, how to manage that, how do we develop root systems without that, and that's what I'm going to talk to you briefly about today. So in our group, we've spent a lot of time looking at root systems. We've spent a lot of time wrecking trees, destroying roots, killing trees that look nice otherwise. But with respect to propagation research, we did have a few questions a number of years ago when we started working on these projects. And one of the things that we see quite often in terms of the liners or the propagation trays that are available on the market is, there's different things that are promoted in terms of quality control for root production. And one of the things we see is the shape of the cell. So this is a question that we researched a number of years ago, and we just looked at, there's all sorts of different shapes you can get out there for the actual propagation shape cell. And what we wanted to know is, does the shape actually make a difference? Did it have an effect on the species that we were interested in looking at? And in terms of the species that we tested, and certainly we haven't tested everything, the shape of the cell actually didn't have that much of an influence. And I do say, there is species differences. So certainly there's going to be some species or different types of products that you're growing that the shape might actually have more of an influence. But in terms of the tree species that we were looking at, that wasn't sort of the main influencing factor that we found. What we did find was trees that were grown in different trays with different amounts of cell openness, so porosity or air pruning holes or slits. That did make a big difference, and I'll talk some more about that, but that did influence root quality in terms of the structural roots formation and the amount of roots that were misdirected, or the weight of roots that were misdirected. And we also found this tray basin, or the drainage hole design, was another influencing factor. So in terms of many trays on the market, everything has a drainage hole for obvious reasons. And the drainage hole does have an impact on the structural root formation, especially for taprooting species. And I'll talk a little bit about why that is. So today I'm mostly going to focus on cell openness, but the drainage hole and cell openness kind of go hand in hand in terms of the design of some of these trays. So I want to talk about what containers, or what trees actually do, and walk you through why we see what we see with a lot of species. And I'm giving an example of here in nature, when a tree with an aggressive taprooting species or something like that will continue to grow until it hits a physical barrier, like a hard pan in the soil. And then it has to change course at the point. It has to, I don't want to say the word, make the analogy of a decision, but something is signaled within the tree and it changes course at that point. So in containers, what we see is that drainage hole acts like that change in environment, because at the point where the drainage hole is, if trays are elevated off the ground, you have some air, you have a pocket of air there that signals to the tree that it's no longer growing in the soil anymore, it's no longer growing in the media, and it has to change course. So what this actually looks like is you have this root that's growing down drainage hole where the air is, and this air exposure provides a hormone signal to the root to stop growing. So the hormone basically converts that environmental stimulus into this physiological or anatomical response. And you end up with the auxin concentrations increasing and the surrounding tissue responding by generating this adventitious root growth. So in solid walled containers, something like this, where you see roots that are emerging because there's root branching happening at that point where the root has experienced that change in environmental gradient. So this is sort of a typical example of what you see in a solid walled container. You can see that there are roots sort of gathering down here where the root branching occurs. There's mostly roots sort of diving down the sides of the solid walled container, and this is where most of the root tips terminate in these kinds of containers. So what happens in an air pruning container that is different is, similarly, the taproot is going to continue to grow until it hits that area that is not well suited to growth, or where the air exposure signals to the tree that it has to change course. And it tells it the same thing to signal, it signals to halt the growth of the taproot. You have the auxin concentrations increasing and the surrounding tissue responding by generating that adventitious root growth right here. But if you have walls that are entirely open, so in a situation where you have a really, really porous container, high exposure of air, you have that happening again. So then that auxin concentration in those roots that just emerged are going to increase, and then you have that generation of adventitious root growth again and again, all the way up the container wall. And this is what in forestry they call the fishbone type of root system, where you have this laddering effect happening. And this is really advantageous, because if you think about where you have these root tips that are radially oriented around the trunk, and they're all pointing outward. So if we think about the way a tree actually grows into soil, the topmost layer of soil is going to be where you have high porosity. It's where you have your nutrients, your biological activity, and all of those root tips are going to be positioned into that space, as opposed to the solid walled containers where you have all the root tips terminating at the bottom and not really positioned where they're going to be able to take the best advantage of the situation. So this is an example of an air pruning container where the taproot or the main root was aborted here because it hit the drainage hole at the basin. But then you start to see this laddering effect of roots up the side of the wall. So this is, this is not a finished tree, but this is where you can start to see these root tips that are getting aborted every time they reach that exterior of the substrate and they hit the air, and it forces that branching all the way back along the main root. So one of the things that we've been doing in our group is trying to figure out, can we design a system? Like, what does the system actually look like where it could develop these high quality root systems? So after a number of years of research and just testing out and evaluating different tray features, we actually did design a tray to capture those beneficial features, which is called RootSmart. And I've included AMA Horticulture's logo because AMA is a partner on this project and carries RootSmart now. And what we did in this is we really tried to think about some of those features I was talking about before, and with the tray basin being a really key feature, We tested a lot of different kinds of basins in terms of the angle and the openness of the basin in order to determine what was the sort of the best situation. And then also the tray itself. So the, you know, the structure of the tray to maximize that air pruning to capture the benefits of air pruning up the entirety of the cell wall. So the remainder of the presentation, I'm just going to look at the differences between, using an opened air pruning tray to semi-open and closed wall trays to really illustrate the difference you can have during propagation and also the effect during establishment in the field. So what we've been doing as we think back to our high quality root system objectives is we really are trying to evaluate what these root systems look like in terms of these objective goals. So no misdirected roots, few roots on the outside of the root ball, some straight roots, some at the surface, that whole sort of gambit when we're evaluating the quality of these root systems coming out of propagation. To figure out how that helps or hinders trees as they're establishing in a nursery field or actually into an urban landscape. So during greenhouse propagation, the things that we have been looking at is looking at misdirected roots inside the liner imprint, the weight of the coarse root system in terms of the defected roots versus the non-defected roots. And then we look at some of these other sort of factors after when they're planted out into the landscape. So in the propagation trial, we looked at tray effects on a number of different species, but today I'm just going to focus on Populus deltoides, because it's a super fun species to grow. And these are just some images, some screenshots or some images we've captured of these different kinds of root systems that come out of a closed wall tray. So walls are roughly 100% closed except for the drainage hole at the basin. The semi-open tray, which is a tray that is roughly 50% plastic. So it's just strategically placed holes around the exterior of the container or the cell. And then also a drainage hole at the basin, and then the open wall tray, which is greater than 95% open on the walls and less than 5% contact at the base. And one of the things we looked at is what kinds of defects are typical or commonly and it's the tray we tested, but a number of trays we've tested over the years, that we get this descending root defect. And this is problematic because what is typical in these kinds of closed-walled cells is we end up with a few roots, so a fewer total number of roots, and with most of the root tips terminating at that drainage hole. So you get long, skinny roots with everything sort of gathering down here. With semi-open systems, it's interesting because you do sometimes end up with a pretty decent root system, but you also end up with these diving roots, because a lot of times, especially in Populus deltoides, it'll try to sort of avoid that air hole, and it can sort of hide behind the plastic. And you can also end up with circling roots for the same reason. So if the roots are able to sort of tuck in behind and aren't actually hit by the porous space on the side of the container, then you still end up with a number of root defects existing. And with open walled containers, we just simply didn't see the same number of root defects because the walls are completely open. And as I demonstrated before, this is really advantageous for sort of creating this laddering effect backwards up the root system. So here I'm just demonstrating what we saw in terms of the percent number of defects on the different container types. So we see the most amount of defects in solid walled containers. And that's not really surprising because we're starting to learn a lot more about what solid walled containers actually do. But what was most interesting is it really is this sort of nice stair-step effect that you have the most defects in solid walls, you have the sort of a moderate amount in these semi-open systems, and then you have the fewest amount in the open trays. This really did confirm for us that that air pruning does have this beneficial effect, and that the amount of air pruning actually really does matter in terms of the percentage of defects we see. So when we're looking at propagation compared to how things establish in the field, we start to look at a number of different parameters as well. So we look at the weight of the coarse root system, both the defected and non-defected, but we also start to look at how those structural roots are interacting with the soil as well. So we look at coarse root angles from years 1 to 3. We're looking at structural root position exiting the root ball, the orientation of the roots exiting the root ball, and the points of anchorage in the soil. And this is a 5-year trial we're running. So we're at year 3 right now, and we've been capturing a lot of data on it. But I just wanted to highlight the fact that we're not actually finished yet. We're still going on it. And this is just some images of how we think about the methods in terms of angle. So when I was talking about this, this 90-degree angle between the trunk and the structural roots, this is what we're measuring for. So we're really thinking about the geometry of this root system in the soil ecosystem itself. So we're thinking about where are the roots exiting in terms of this circumference, and we're also thinking about where they're positioned in that soil in terms of this angle as well, because we know that roots that are closer to 90-degree angles do have a greater structural stability anchorage point, and this has been demonstrated by some really great work out of the University of Florida. So here we'll just wrap up quickly with the production and the establishment trial, but what was really consistent throughout is this proportion of coarse root defects decreases with increasing openness, and we have a meaningful and lasting impact by starting out with a really high quality root system. So this is what you do in the propagation stage is still consistent in the field. So there isn't, a magic change that happens. These things are sort of persistent. The other thing we're starting to see now in sort of the final years of this trial is we're looking at the effect of this defect rate and how that actually affects trees' anchorage in the soil. So closed wall trays with a 25% defect rate in 2019 in the propagation trial and earlier had a sort of limitations in terms of their anchorage points in the soil. So what we see is there's only 3 major anchor points in the soil, and this is problematic when we see trees in high wind situations, certainly. And then finally, the open wall tray, where we had lower percentages of defect rates, after 2 years in the soil, we see a much higher percentage of anchorage points in the soil. So in this case, we're showing 6 anchor points, and you can see in terms of those quadrants that we're looking at, there's a greater distribution sort of around that circumference. So this is something that is exciting for us, and it shows us that this is tracking and this trend is continuing. So the wrap up here is that coarse root development starts early. It's important to pay attention as soon as you can to this. Many trays or containers on the market are promoting air pruning, but there's like a ratio of 80 to 20%, so 80% plastic to 20% air pruning. What we're recommending is look for the opposite. You want to be looking for higher amounts of air pruning and lower amounts of plastic, because the plastic is an opportunity for root to tuck in behind and cause a defect. And then the other thing that we're seeing is that deflected roots in propagation are sustained in the field after planting. So this is confirmed by us and others, but this is an important note for producers and certainly for finishing producers who are looking at and evaluating stock that they're buying in. And we're seeing that more and more. And the other sort of big piece of this is that the negative impacts of deflected coarse roots in nursery stock may not become apparent for several years. So it might not be a problem until you're in a situation where you have high winds or you have something else going on in terms of tree stress. So it's important to pay attention to these quality factors, at every stage of production as you move along. So just a couple acknowledgements. I want to thank AMA Horticulture for their support and partnership. I also want to thank Verbinen's Nursery and Alex Verbinen for providing materials, time, and expertise before and continuously in our program. And thank you to my team, Jason, Ryan, and Charlene. I think some of them are on the call. And then if you have any questions, you can always visit our website and email me. And then certainly for more information about RootSmart, you can visit that website. So thank you for listening.